Hello viewers, welcome to MAGESH classes. In this presentation we are going to discuss about TRB PG Chemistry questions asked in 2011 and 2012. Here total 110 questions. In part 1 we will discuss 20 questions. Let us move into the question part. Question number 1. The number of lines in the ESR spectrum of this benzene. So in case of ESR spectrum, number of lines is given by the formula 2ni plus 1. Here n is the number of atoms and I is the nuclear quantum number. Here the n is equal to Benson radical, n is equal to 6 and I value for hydrogen is 1 by 2. So number of line is equal to 2 into 6 into 1 by 2 plus 1. By cancelling you get 6 plus 1 is equal to 7. So the number of lines are 7. So it is very simple problem. Question number 2. The signal for CH2 will be split into dash in the PMR spectrum of the phenol, ethyl phenyl ether. In the NMR spectroscopy, the splitting pattern is given by the formula n plus 1. The n is equal to number of neighboring hydrogen. In the formula H5OCH2CH3, the neighboring atom with the nuclear spin is 3, hydrogen atom. So 3 plus 1 is equal to 4. So this line will split into 4. Your answer is B. Question number 3. Which among the following will have highest crystal field splitting? K4FeCl6, K4FeBr6. The ferrous ion have the plus 2 oxidation state, and it is also plus 2 oxidation state. The crystal field splitting energy depends upon the geometry. So from geometry we know that the tetrahedral, octahedral and the square planar. This is in the order. And then from oxidation state, central metal ion oxidation state increases, CFSA also increases. Third one, d electron increases, CFSA also increases. Fourth one, size of the d orbital, the increasing order of 3d, 4d, 5d. As size of the d orbital increases, then the CFSA also increases. Then fifth one, types of ligands. The types of ligands and the ability of splitting the d orbital is given by the spectrochemical series. Okay. So in this problem, the central metal ion having the same oxidation state, all are having plus 2 state, and geometry also same. And number of the d electrons. Number of the d electrons in this case, it is the d6 case. So all the case it is d6 system. And all the Fe are in the 3d orbitals. So the factor is depends upon the types of ligand. So various ligands are present. It is based on the spectrochemical series. The splitting pattern is in the order. Here the I, then Br, Cl, F, halogen in the order. And cyanide is a strong ligand. So the splitting of cyanide is very high. And so they will have highest crystal field splitting is in the C. Question number 4. Which among the following will show minimum mass by a isomer shift? The isomer shift in the mass by spectroscopy is depends upon the s electron density of the nucleus. As s electron density increases, number of s electron increases, the mass per isomer shift in the negative direction increases. As the d electron increases, the shielding of s electrons also increases, and so the s electron density decreases. So negative shift also decreases. Here the first complex, it is in the plus 3 state D5 system, plus 3 state D5 system, plus 2 state D4 system, and plus 3 D5 system. When you compare the S electron density in the Fe atom, Fe0, it is 4s2 3d6, and Fe2 plus it is d6, and Fe plus 3 it is d5. So more number of d electron is present in the Fe2 plus, and so S electron density decreases. The isomer shift on the negative side also decreases, so it is in the positive side. Okay, so when you compare the shift in the Fe and Fe3 plus, we follow the order Fe, then Fe3 plus, and Fe2 plus. So plus 2 and plus 3, Fe plus 3 has minimum shift, so C may not be the answer. In case of A, the amine is present, here the phosphine, triphenyl phosphine, here the cobalt. The splitting order of amine and phosphine is in the order. So more splitting is present in the carbonyl complexes. So as more splitting takes place, the S electron density is maximum, and so the shifting in the negative direction is increases among these complexes. So the D possesses minimum mass pair isomer shift. So our answer is D. By summarizing, the S electron density increases, it has lower shifting value, the negative side. As the D electron increases, the positive shift also increases in case of Fe2 plus. Among the Fe3 plus complex, the more is the splitting, the electron density is maximum, and so minimum is the isomer shift. Isomer shift is nothing. It is a measure of the difference in S electron density of the sample and the source. In mass-based spectroscopy, the source is, in mass-based spectroscopy, cobalt is used as a source. Next question, which of the following is colorless in aqueous solution? If the ion having d orbitals in unpaired electron, then it is colored. Based on electronic configuration, the 182 plus, the atomic number is 23. Electronic configuration 4:3d3. So it has 3D system, and copper plus is 310 system. 4 is 1d10 and copper plus is d10. It is d6 system, 4:d6, and cobalt 2 plus is a d7 system. Among the four, the d10 has no unpaired electron. So due to no unpaired electron, it is colorless. Our answer is B. Next question, the number of H1 NMR signals observed in cyclopentanone is. The number of signals in the NMR spectroscopy is equal to the types of hydrogen. Okay, cyclopentanone structure is CH. The type of hydrogen, it is one type, this is A type, and this is A type. It is flanked by the carbonyl group, and it is another type, it is a B, and it is a B type. So there are two types of hydrogen. And so the number of signals also 2. Your answer is D. DPPH is used as a standard in gas spectroscopy. It is a direct question. Your answer is EPR, electron spin spectroscopy. In case of EPR spectroscopy, the source is microwave. The standard is DPPH. The DPPH is nothing. It is alpha dash diphenyl picryl hydroxyl radical. So it is used as a standard in the EPR spectroscopy, but the source of the spectroscopy is microwave. Okay, our answer is EPR. Next question, which among the following are not aromatic? Aniline, naphthalene, 18 aniline, and tropylium ions are given. Aniline. Anilines are monocyclic ring with alternative double bond. So the number in the square bracket indicates the number of carbon atom. So it is called 8 aniline. 8 aniline. Anilines having even number of carbon atoms, the aniline 26 and 28 does not exist. And in the case of 8 aniline rule, it follows 4 in electron, but this complex is non-planar in structure. So due to its non-planarity, it is non-aromatic. So your answer is 8 aniline. In case of anilines, the 8, 10, 16 are the non-aromatic. And the 12 is anti-aromatic and 14 is aromatic. So this is because of the structural nature and by electron nature. From 18, all are aromatic in nature. Okay, so the 8 aniline is non-aromatic, 10 aniline is non-aromatic, and 12 is the anti-aromatic because the complex is non-planar, but it does not follow 4n plus 2, it follows 4n rule. And in case of aromatic in nature, it follows 4n plus 2, it is aromatic in nature, and 18 is aromatic, 16 is non-aromatic. So 8, 10 and 16 are non-aromatic. 18 aniline is the aromatic, and naphthalene is the benzenide compound, and so it is the aromatic nature. And a tropylium ion is nothing, it is a heptadiene compound plus. So it has 6 by electron, follows plus 4n plus 2 rule, and this molecule is planar, so it is aromatic. So it is a benzenide aromatic. Non-aromatic species is the 8 aniline. Benzene reacts with non-propyl chloride in the presence of anhydrous aluminum chloride to yield. So it is a type of Friedel-Crafts reaction. Friedel-Crafts reaction is nothing, it is the alkylation of benzene in the presence of anhydrous aluminum chloride to give the alkyl benzene and HCl. So in the mechanism, what happens? The alkyl halide or X is treated with AlCl3. So there is a transition state is forms. It is a fractional plus, and AlCl3 fractional minus. It is an electron deficient species, and so it attracts an electron. This transition state reacts with the benzene. The positive corner of the alkyl approaches towards the benzene nucleus. You get the R plus rhenium ion is formed, and here you get AlCl minus. Here the R plus, the plus is present in the carbon part, and so it is a typical carbocation, and the adjacent hydrogen atom is displaced. You get the product, the alkyl benzene, and this HCl and plus AlCl3 is recovered. The rate of the reaction K is equal to the concentration of benzene and the concentration of the Lewis acid and the concentration of alkyl halide. The order is 3. In case of benzene with normal propyl chloride CH3, CH2, CH2Cl, the product, the expected product is like this: CH2, CH2, CH3. In this case, the intermediate formed is like this: CH2, CH2, CH2 plus. This is the primary carbocation. The stability order of the primary carbocation, secondary carbocation, and tertiary carbocation, the order is like this: secondary and then tertiary, so that it rearranges itself to form the transition carbocation is like this: CH3, CH3 plus. Then this hydrogen ion is transferred to give the isopropyl benzene is formed. So your product is D, not A. Okay. Next question: which among the following is an electrophile in aromatic sulfonation reaction? Aromatic sulfonation reaction, the benzene is treated with the concentrated sulfuric acid in the presence of the catalyst, again the sulfuric acid. To yield the product, the sulfonated product is this. What is the electrophile here? When you consider the mechanism, in the first step is a generation of electrophile. Sulfuric acid reacts with another sulfuric acid. The electrophiles are generated: SO3 plus HSO4 minus plus H3O plus, hydrated water molecule. Then the second step, attack of electrophiles on the benzene nucleus. Benzene nucleus and sulfur dioxide. It is an electrophile here. Here it, due to the more electron activity, it will be minus, and the electron is, the sulfur dioxide is connected, and so it carries the positive charge. And the third step is the deprotonation of this species. This intermediate is gets deprotonated. Here the positive charge is present. O minus, double bond O, double bond. It is deprotonated by the bisulfate ion. It brings one hydrogen atom here. So here it is a hydrogen atom. You get this product. Go minus and sulfuric acid. In the fourth step, there is a protonation. The protonated species is like this. The final product is O3 minus plus H plus ion from the hydronium ion. You get this product: benzene sulfonic acid. The sulfuric acid is recorded as a catalyst. 1 mole of sulfuric acid is utilized. DSO3. The next one, the multiplicity of a proton in the 1H NMR spectrum of this compound. The given compound is CH3 twice COH CH2 Cl. By expanding you get CH3 CH3 CH2 Cl. The question is the multiplicity of the proton of the 1H NMR. The spin multiplicity depends upon the formula n plus 1, number of splitting atom. N is the number of neighboring atom. So in this case, there is no neighboring atom. For example, when CH3 is considered, there is no neighboring atom. So here no place. This CH3 has no neighboring hydrogen atom. And so this hydrogen also have no neighboring hydrogen atom. And this hydrogen also having no neighboring hydrogen atom. And so the multiplicity is not observed. And n is equal to 0. You get 0 plus 1. It is singlet A. Next question. When nu I minus nu S is negative, then the line is. So it is the Raman spectroscopy. When nu I, the frequency is the incident radiation. And mu S is the scattering radiation. The Raman spectroscopy, in classical Raman spectroscopy, the nu R is the Raman frequency. It is the Raman frequency. The classical approach, the incident radiation is fall under species. The species can absorb the energy or release the energy, and so the scattering frequency is greater than the incident frequency, or the scattering frequency is less than the incident frequency. It is mu I, incident minus mu S. In case of absorption, if the species absorbs some amount of energy, it is a substance in question, absorbs some energy, and so the emitted frequency, that is mu S, is less. So mu I is greater and mu S is lesser, and so the mu R is the positive. Here the absorption of the radiation takes place. Okay. In case 2, mu R is negative. So in this case, the release of, that is the some amount of energy is released to the incident radiation. So there are two cases. Raman frequency is positive or Raman frequency is negative. When mu R is positive, that's mean the incident radiation is greater than that of the scattering. In mu R is negative, that is mu I, that the incident is less than that of the mu S. Here the given question, mu I minus mu S is negative, that is mu S is greater than mu I. This is the case. Mu S is greater than mu I. Okay. So the Raman frequency is negative. It is said to be anti-Stokes lines. Our answer is C. Next question, which among the following does not show quadrufold splitting in mass pair spectroscopy? So in mass pair spectroscopy, quadrufold splitting is due to the asymmetric electronic distribution in a compound. Asymmetric electronic distribution is the criteria to show the quadrufold splitting in the mass pair spectroscopy. When you consider the first complex, the A, the electronic configuration is, in case of A, the Fe is in the 3-state and it is D5 system. The electronic configuration is T2G 5 Eg is 0. So it is a low spin complex. The splitting is higher. So it is a asymmetric in nature. And so it's so quadrufold splitting. The quadrufold splitting is due to the asymmetric electronic distribution of the compound. So it shows quadrufold splitting. Then you compare the B. B also, in the case of Fe3 oxidation state, CN6 potassium ferrous cyanide. So it is a D5 low spin, T2G5 Eg0. It is asymmetric. It's so quadrufold splitting. And C, the Fe is in the +2 state. So it is D6 and it is low spin. The electronic configuration is T2G 6 Eg0. Okay. So it is the symmetric one. Does not show quadrufold splitting in the mass pair spectroscopy. In case of D, it is also Fe2 plus. The ligand is weak ligand water, and so it is a high spin. The electronic configuration is T2G 4 Eg2. So again it is the asymmetric. So the symmetric one is the Fe D6 low spin complex. So our answer is C. Next question, the ionization energy can be found by using NMR, Raman, ESR and PS. So it is by photoelectron spectroscopy. The answer is PES. In photoelectron spectroscopy, the concept is the energy of the ejected electron is equal to h nu minus I. In photoelectron spectroscopy, the energy is fall on the thin spile of the metal, and the electrons are ejected with energy from the valence shell. So energy of the ejected electron is equal to the energy of the incident radiation, that is incident minus the energy, kinetic energy, that is nothing. It is the ionization energy of the electron. So the ionization energy can be calculated by using photoelectron spectroscopy. The next question, the source of NQR spectroscopy is. Your answer is direct question. It is a radio frequency radio wave. Here the microwave spectroscopy is given. It is a rotational spectroscopy. And in case of IR spectrum, it is called IR spectroscopy. And it is X-ray photoelectron spectroscopy. Next question, the source of NQR spectroscopy is radio frequency radio wave. Answer is C, it is a direct question. The option A, the microwave is given. The microwave, the EPR spectroscopy and the rotational spectroscopy are observed. And the IR spectroscopy, the name itself, it is IR. And the X-ray, you can use photoelectron spectroscopy, X-ray photoelectron spectroscopy. One more spectroscopy, that is UV. This is a common photoelectron spectroscopy. In case of X-rays, gamma rays are used in the mass wire spectroscopy. The answer is radio frequency. Question 16. The given polymer is isotactic polymer, atactic, syndiotactic, and irregular polymer. The polymers are classified on the basis of tacticity. There are three types: isotactic, atactic, and syndiotactic. The tacticity means the orientation of monomer units in a polymer molecule with respect to the main chain. So the main chain, how extend the monomers are oriented along with the main chain is said to be tacticity. In case of isotactic, the side groups of the monomers lie on the same side. That is isotactic. Suppose it's the main chain. The side chains are attached on the same side. It is called isotactic. And in syndiotactic, what happens? The side chains are arranged in the alternate manner. Here one X, and here one X, here X. So alternate it is arranged. It is called syndiotactic. Okay. Then the third one, atactic. The side groups are arranged in an irregular pattern, as in the random manner around the main chain. If it is the main chain, what happens? The X, here on X, randomly arranged, and there is no rules at all. This type is called atactic. That means there is no tacticity. So in case of this polymer, this side chain is alternatively arranged in a regular pattern, and so it is called syndiotactic polymer. Answer is C. Next question, which among the following is inorganic polymer? So in case of polyvinyl chloride, it is the polymer of vinyl chloride, that is CH2 double bond CH here. It is a polymer of vinyl chloride. It is an aromatic. It is an organic polymer. And Pacolite is the organic polymer. It is a combination of phenol and formaldehyde. It is a polymer of phenol and formaldehyde. And nylon is the polymer of adipic acid and methylene tetramine. So it is the organic polymer. And the third one, D, it is a silicone. It is the inorganic polymer. It is a polymer of silicone. So answer is silicone. Silicone is not given. So it is based on the chemical reactions of polymers are two types: addition polymer and condensation polymer. In addition polymer, the monomer is involved. In case of condensation polymer, different types of monomer are used. Two different monomer is involved in the condensation product. And also, in case of addition polymer, does not lead to loss of any smaller molecules. In condensation polymer leads to loss of simple molecules like water and HCl. And the empirical formula is same as that of the combination of the monomer. It is different. In case of polyester, it is a combination of ethylene glycol and terephthalic acid. It is combination of ethylene glycol and terephthalic acid. Nylon 6,6, it is a combination of adipic acid and hexamethylene tetramine, discussed in the previous question. And bakelite is a combination of phenol and formaldehyde. And polystyrene. Polystyrene is a combination of single monomer. So it is the addition polymer. And so, which is not a condensation polymer, the polystyrene is not a condensation polymer. It is the addition polymer because it involves only one monomer. Others are condensation polymer because it involves two different monomers. Here ethylene glycol and terephthalate, nylon 6,6, two different monomer, and bakelite, two different monomers. So your answer is C. Next question, which is inorganic benzene. The inorganic benzene is nothing. It is a direct question. It is also known as borosol or the borosine. The molecular formula of this borosine is B3N3H6. So the answer is C. In addition to that, it is the benzene and borosine, inorganic benzene, are also known as isosters. The combination of this benzene and borosine or inorganic benzene is called isosters. Isosters having same number of atoms and electron. These two are same. For example, in case of benzene, how many atoms are present? 12 atoms are present, and total you have number of electrons are 42. So 6 electron from each carbon atom. So 36 plus 6, 42 electrons. And you can count the number of atoms and number of electrons also, 42 electrons and 12 atoms. And so these pieces are called isosters. The next question, the bakelite is nothing. It is a combination of phenol and formaldehyde, and so it is called phenol resin. And what are resin? Resin is the amorphous solid or the semi-solid, and it is a product of complex chemicals having large number of carbon atoms. So it is a complex having large number of carbon atoms. So it is in the form of amorphous solid or semi-solid. Phenol resin bakelite is a combination of phenol and formaldehyde, and phenol and formaldehydes are joined together by the many number of CH2 groups. So present in it is also attached in the para position also. Here the CH2 group. So it is a large number of carbon atom present, and it is a solid or semi-solid. It is a semi-solid thermostatic plastics. So phenol resin is nothing. It is a bakelite. Okay, viewers, up to this we have stopped this presentation. We will meet in the next part from the question number 21. I hope that it is useful to you. Thank you for giving your time, and thank you for watching.